Alright guys, today we're going to go ahead and do section 162. We're going to apply laws of sines and cosines to real life problems. I've already written this question. This makes the second time now, so for some reason the document camera continues to freeze up. See if it'll actually let me record this time. So, example 1. 2 fire lookout stations are 13 miles apart, with Station B directly east of Station A. Both stations spot a fire. The bearing of the fire from Station A is north 35 degrees east, and the bearing from Station B is north 49 degrees west. So I'll read that sentence again. The bearing of the fire from Station A is north 35 degrees east, and the bearing from Station B is north 49 degrees west. How far to the nearest tenth of a mile is the fire from Station B? Now, a lot of you guys, as you're finishing copying this problem, are confused about when to do law of sines and when to do law of cosines. You know what? You can always, if you're in doubt, always set up law of sines and see if you have enough information to use it. Of the two choices, you'd always prefer to use law of sines. It's just quicker. Alright, so if you haven't finished copying down this problem, go ahead and just pause the video and then get yourself to finish. And I'm going to go ahead and draw a picture. So I have location, I have fire station A, and east of it I have fire station B. And I'm told that these are 13 miles apart. Now this is a bearing problem. So what I'm going to do is go to station A, and I'm going to kind of draw in my little compass. So I am north 35 degrees east. So remember, we feed off of north and south, 35 degrees east. Okay, so here's my fire. Likewise, from Station B, the fire is north 49 degrees west. So again, I can draw my little compass, and I know I'm north 49 degrees west. My question is, how far is the fire from Station B? So really what I want to know is this piece. Well, what does this angle, what is this bearing angle? Isn't this angle 90 degrees? So how could I find the missing piece? And what I'm going to do is take a second and just redraw it. Well, if this entire thing is 90 and this is 35, do you agree I could do 90 minus 35 and find out that this is a 55-degree angle? Can I also do the same thing over here? This is again a right angle, so they're complementary angles, so this one has to be 41 degrees, and I'm looking for X. Okay? Or we can call it anything we want. So if you want to go back to what you've been doing, A, B, and C, then call him little a. So now I'm going to go ahead and just try to set up law of sines, and maybe it'll work. So I'm going to do little a is to the sine of 55, oops, I forgot that there's a 13 there, as 13 is to the sine of, well, wait a minute, do I know C? Yes, I do, because isn't C part of a triangle? So can't I do 180 minus 55 and 41? So 180 minus that 96 gives me 84 degrees. Now, if it truly can be done with law of sines, you're going to only have one missing item, which is what I do. So you're going to grab your handy-dandy calculator, and you're going to go ahead and use law of sines. Now, I'm going to write down all my work, but I'm hopeful that most of you have gotten to the point where you don't need to show all of this. So it's A times the sine of 84 equals 13 sine of 55. I want to get A by itself, so I divide by the sine of 84. So I grab my calculator, 13 times sine 55 divided by sine 84. And I get that A is 10.7 miles. Okay? Alright, well, so far the projector is hanging in there, so let's see if it'll hang in there for question number 2. 2 airplanes leave an airport. So 2 airplanes leave an airport at the same time on different runways. One flies directly north, at 400 miles per hour. The other flies on a bearing north 75 degrees east at 350 miles per hour. How far apart are they after 2 hours? I keep stopping and letting it clear in hopes that it doesn't quit recording again. Alright, so 2 airplanes leave an airport at the same time on different runways. One flies directly north, the other flies on a bearing north 75 degrees east. How far are they apart after 2 hours? So let's go ahead and draw ourselves a picture. Here's my first airplane. He goes directly north. Now, he flies at 400 miles per hour, but I want to know 2 hours. So in 2 hours, assuming that he goes 400 miles per hour, how far has he gone? He's gone 800 miles. Now my other plane takes off, but he's flying at a different bearing. So let me go ahead and draw in our little thing. So he took off on a different runway, and he flies north 75 degrees east. So here's my other airplane. So north 75 degrees east. And he goes 350 miles per hour, so in 2 hours he has gone 700. My question is then, how far apart are they? So I'm looking for this piece, X. Okay, so if we'd like to, we can go ahead and take the triangle totally out of its picture. Here's 700, here's 800, here's X. We know that's 75 degrees. So if you attempt the law of sines, let's call this A, B, and C. You'd say little a is to sine of 75, as 700 is to sine of B, as 800 is to sine of C. So do you see why law of sines isn't going to work? It's not going to work because he has a variable, he has a variable, and he has a variable. So we have to scrap this, and we have to say, well, maybe I can do law of cosines then. And if you remember law of cosines, if you have an angle, that's the side I want to start with. So I'm going to do a squared equals b squared plus c squared minus 2bc cosine A. Alright, so a squared equals, little b is 700, little c is 800, minus 2 times 700 times 800 cosine 75. Now, take a quick gander. you are finding the side, which means we can just grab our calculator and go. Alright, so type in 700 squared plus 800 squared minus 2 times 700 times 800 times cosine 75. Now, be careful. A lot of you guys have been making the mistake of saying, woohoo, look, I'm done. But what do you need to do with this number? You now need to take a square root. And I get that the distance the planes are is 816.6 miles. So, you know what? Feel free again to always try to set up law signs, and then you'll know beyond a shadow of a doubt. Okay? Alright, the last problem I want to do with you is an area problem, since we haven't done those in a few days. And hopefully I can get it done before time. I am going to try to get this video to run short tonight, and I'm going to give you 5 problems that, again, need to be done in the morning for credit. Alright, so let's do the last example. And actually, guys, I think we're just going to go ahead and wrap it up here tonight, since I am giving you those 5 problems that you have to complete. Alright, so after having an argument with myself, we are going to go ahead and do number 3 tonight. You'll get that later. A piece of commercial real estate is priced at $4.50 per square foot. Find the cost to the nearest dollar of a triangular lot measuring 320 feet, 510 feet, and 410 feet. So start off by drawing your triangle, and you can label any side you want: 310, 510, and 410. So this one is different in that you need to figure out, what do you need to know about this triangle for you to be able to figure out how much it's going to cost? You need area. So think back several days ago. Do you remember you had 2 formulas for area? You have Heron's formula, and then you had that other formula. So we're going to use Heron's formula since we have all our sides. So it was the square root of S, S minus A, S minus B, S minus C. And do you remember what S was? S is half of the perimeter. Okay, so I do 320 plus 510 plus 410, take half of it, and we find out that S is 620. So now to find the area, I do 620 times 620 minus 510, 620 minus 410, and 620 minus 320. Alright, if you'd like, you can go ahead and type that whole thing into your calculator. So the square root and you find out that the area is 65,548.45 square feet. But the original problem said you had to pay $4.50 per square foot. So what would you do? So it costs you $4.50 per square foot times the 65,548.45 feet that you have. which means the property is going to cost you $294,968.05. Alright, so that's it, and I will see you guys tomorrow. Don't forget to do the 5 practice problems.